So in the last class, we discussed about the classification. In the classification, we discussed binary classification. We discussed multi-class classification with the examples. Okay. Next is the multi-level classification. Anyone can tell me what is the difference between multi-class and multi-level classification? Say here. Okay, suppose you are having an image. You are having an image, only one image. Okay, and in this image you are having a dog. In this image you are having cat, and in this image you are also having a cow. So and you are having a lot of images. Okay, so a particular image have different kind of information. So each example, that means each image, that means each example have more than one class level. One class is this, one class is this, and one class is this. So this is called multi-level classification. Multi-level, in the definition, multi-level classification refers to those classification that have two or more class levels. Two or more class level, where one or more class level may be predicted for each example, just like your group image. Okay, in the Facebook you are having a group image, and the Facebook identify each image and then a tag, okay, this is you and this is you and this is you. You got my point? Each example have more than two, each example have two or more than two class levels. This is called multi-level classification. And in multi-classification, what we have? We have different examples or different data like this. Yeah, this may be the dog, this may be the cat, this may be the cow, this may be the cat, this may be the cow. Clear? So you are having a lot for image perspective. Suppose you are having hundreds images and you are having three class, dog, cat, and cow. So out of these hundreds images, some images are for cow, some images are for cat, some images are for dog. But in case of multi-level classification, each image may have two or more than two class level. So this is clear. What is multi-level classification? Yes or no?
Yes.
Okay, so this is different from binary classification and multi-class classification, because in binary and multi-class classification, we need to deal with a single class have single predicted value. Single class, where a single class level is predicted for each example. But here, more than one class level is predicted for each example. So this is the difference here. So for some algorithms are there for multi-level class classification, decision tree, multi-level decision tree, random forest, and gradient boosting. Okay. Okay, so this one is clear. Now next one is the imbalance classification. Imbalance itself will give the definition about this. Imbalance means the data is not balance. That means suppose you are having a millions of samples, and in that millions of samples, maybe some samples have some kind of noise or something that is not required. Okay. So it refers to the classification task where the number of example in each class is unequally distributed. Okay. That means suppose I have given one example yesterday. Suppose you are having some survey related to the what they are expecting from their company, and the user or the people who are giving service are two kind, male and female. Male and female. But there may be the case that maybe 990 male give service and only 10 females have given the survey. So this is, you can say this is an imbalance. Okay. So classification where number of examples in each class is unequally distributed. Clear? So these are unequally distributed. And typically imbalanced classification tasks are binary. Generally, these are a binary classification where the majority of the examples in the training dataset belongs to the normal class. So suppose I will give you an example like cancer and non-cancer images. Non-cancer images. So this is normal and this is abnormal. Okay. Suppose you may have an data set where you are having too many images for cancer. This is abnormal and this is normal. Okay. Non-cancer. Suppose you are having a lot of images for non-cancerous patients and a few images for cancerous patients. Okay. So this type of a problem itself is a binary classification, but the data is imbalanced here. Okay. So some examples are, you can see the fraud detection. Suppose internet banking, millions of users are using internet banking throughout a day, but out of these millions, maybe hundreds of them are having some kind of fraud. Okay. Outlier detection, that means something unexpected in some data, maybe in image or maybe something related to machinery, anything it can be. ठीक है. Medical diagnostic test. ठीक है. होता है ना कि sometimes we are having some blood test, and out of 100 there may be the one patient that may have the wrong test reports. So imbalance means the data is not imbalanced here. Clear? What is imbalance classification? Hello.
Yes, sir.
So these problems are modeled as binary classification, okay? But we require some specialized technique. Okay, so random unsampling and smart overlapping. So see, there are a lot of things to learn, but we can't learn each and everything in detail because we have a semester of 4 months. Okay? So we will learn according to the syllabus only. Okay. So in the syllabus, you are having the classification. We discussed the classification. Now in the lab, we will discuss some examples where we will work on the real data set for performing some kind of classification. Okay. Most commonly used classification yesterday I discussed, if you remember, logistic regression, SBM, support vector machine. I also have the mathematical study of the support vector machine. I needed 2 classes, but if I will start going to the mathematics of this support vector machine, it will take 2 class, and I'm not able to finish your syllabus. Okay. So we will not go over the mathematics because it is not in your syllabus, but I have the idea of about the mathematics of this. Okay. So in the lab, we will solve some problem and using the support vector machine, that is most widely used classification algorithm, support vector machine. Okay. So we will discuss. I will also show you a research paper where a researcher used support vector machine for the mammogram classification. Okay. So we will discuss this classification in our lab. Okay. Logistic, yesterday I gave you the mathematical definition, if you remember. F of x is equals to y equals to mx plus c. This is regression, linear regression. And for logistic, just do this 1 upon 1 plus e to the power minus f of x. If you remember yesterday's class,
Yes.
logistic. Yeah. So this is your real value minus infinity to infinity, and this will be your 0 to 1. So we can set some threshold, maybe 0.5. If it is 0 point greater than 0.5, then you can say it is a class 1, otherwise 0. Or you can say class 1, class 2. Okay. So logistic is just the extension of the linear regression, because the name itself have the regression, and logistic means this. ठीक है. So we will discuss support vector machine, and if you want, I will give you the questions related to the logistic regression as well. ठीक है. One class classification, it is just the alternate for the imbalance, as we discussed yesterday as well. ठीक है. So generally, if you search the internet, you will find this one class classification algorithm for imbalanced data that we discussed above. ठीक है. Imbalanced data, that means anomaly detection, fraud detection, outlier detection, nobility detection. Nobility means you are having a lot of data and you just need to find the some noble things. Okay. So this also called one class classification, because you are not classifying in two classes. You are just finding the abnormality, nobility. You are just finding the things that are different from the others. So the alternately we can say it is a one class classification. So one of my friend in his PhD, he worked only on this problem, one class classification. He spent his 5-6 years only on this topic, one class classification. Okay, so now you can imagine how wide these topics are. So this classification is clear.
Yes, sir.
Classification, binary classification, multi-class classification, multi-level classification, and then imbalance classification. Okay. So we discussed these classification. The mathematics, that means in the regression we need to find the minus infinity to minus infinity real value. In the classification we need to find a particular class. Okay. For binary it may be 0 1, it may be spam not spam, it may be male female, it may be cancerous not cancerous. Multi-class, more than two class, just like handwritten digits classification. So the handwritten digits may be 0, maybe 1, maybe 2, maybe 3, and so on. So 0 to 9. Okay. Multi-level, that means each example have two or more than two class. Just like one image may contain multiple objects, maybe cat, maybe dog, maybe cow. Most common example is the Facebook images. So whenever you upload an image, Facebook will suggest tag this friend, tag this friend, tag this friend. Okay. And imbalance classification, when we have some data which is imbalance, you can say. Okay. So now we are moving further. Okay, so further, yeah, yeah. So now next we are having data cleaning in the first module, data transformation, and then data normalization. Okay. So cleaning, I think everyone might be familiar what is cleaning here. So data cleaning is the process by which inaccurate, poorly formatted, or otherwise messy data is organized and corrected. Okay. Okay, an example. Okay, I will give you the example here. See, suppose if you conduct a survey and ask people for their phone number. Okay. So there may be the case that I am giving my phone number in this way. होता है ना. और कभी कभी I am someone is giving phone number in this way. Space दे दिया. Am I right? Someone may use +91 sign. Am I right? So people may enter their phone number in different formats. Same example for the dates. Suppose today is 18, so someone is written in this way. Sorry. Okay, someone has written in this way, and someone has written 18 Feb. Okay. So we have some uneven data. Okay. Other example I will give you. So before it can be used, this data we need to standardize. Okay. Is it clear?
Yes, sir.
ठीक है, I will give you the process, मतलब how data can be. Yeah. So see, how do you clean data? So data cleaning, it is not fixed. It is not guaranteed कि these are the some standard rule. So you can follow these rules for your data cleaning purpose. ठीक है. So first thing keep in mind कि this is not fixed. May vary according to the type of the data. So it will depend on the problem. ठीक है. It will depend on the data and the problem itself. ठीक है. So there is no fixed rocket science rule. ठीक है. Some basic things I can tell you for data cleaning. See, there may be the case of duplicate entries. Okay? So there may be the case of duplicate entries, or there may be some irrelevant observations. Okay? I can open a database and try to show you. Just a minute. Okay, sorry. Okay. I'm opening this data. ठीक है. And suppose इस data में suppose in the square feet living, you can see कि यहाँ पे year of build is in the 4 digit. ठीक है. Suppose I have written in 5 digits. By mistake I have written 5 digits, or zip code is, you can say, the 5 digits. So by mistakenly we have written 6 digits. So you can say this is a kind of a data is irrelevant or messy or duplicates. Means suppose you are having this entry 2 times. You are having this entry 2 times. So you can say it is a duplicate entry. So it is better to delete this. Okay. So you can say the duplicate entries or irrelevant observation, which is not related to our problem. So we can eliminate them. Okay. This one is clear. Next one is the structural error. Okay. Sometimes suppose you are just writing some suppose in your database you are having some animal's name. ठीक है. Suppose cat, किसी में dog लिख दिया, cow, buffalo. So you can see here I am using the small character, here I am using the capital character, capital, or sometimes there may be the case. So now for this I am using this one. So you can see structural error. Structural error when you measure or transfer data and notice strange naming conventions. Suppose you are transferring, we will discuss what is data transformation. So suppose you are transforming data from one form to another form. Okay. So whenever you are performing this transformation, there may be the change of the convention, maybe some typo error there, maybe some incorrect capitalization, anything can be happen. Okay. So this comes under the category of structural error. So sometimes we need to eliminate this structural error as well, or sometimes it doesn't. It depends, again, it depends on the problem and the data. Okay. So duplicates, structural error. Okay. Now missing data, what you can say, suppose this example again. Okay. Now suppose for this house, suppose we are this is not given, suppose this square feet living is not given to us, this entry is deleted. Okay. Can you see this highlighted?
Yes, sir.
Suppose this entry is by mistake, there is no entry for this only highlighted one. Okay. So what you can do now, this example, only this entry is deleted. So can you use this example? No, we can't use until we fixed this one. Until we fixed this one. Okay. So this kind of problem can be in our data itself. So missing values. So there may be the multiple criteria to handle this. I can say tell you the one or two of them. So you can not ignore the missing data because many algorithms will not accept missing data. Okay, so either you need to delete this the whole example. Okay, so what you can do if this entry is missing, okay, there is nothing. So what you can do, you can just delete this row. Yes or no? You can delete this row, or second way, try to find some appropriate value and just fill it. Some appropriate value. Anyone can suggest what we can write here? Any
So mean,
suggestion? Yes, we can use mean value. We can use mean value and we can fill that mean value.
Sir, can we
So
also use median?
it depends on up. You can use medium. There is a no fixed rule actually. There is no fixed rule.
Okay, sir.
है ना? So there is no fixed rule कि मतलब which value is good, which value is not good. और generally जब हम whenever we learn the normalization, then it will be better to decide कि which value you can use. ठीक है? So see, so you cannot ignore. So first you can either you can delete that, or you can input some missing value based on the other observations. ठीक है? Okay, so this is called data cleaning. I had discussed only the three things: duplicate, okay, structural, missing values, okay. But there, these things are not limited. We do not know, matlab, how many things can be in your data. Okay. So we do not know how much we need to clean our data. It again depends on the data. It again depends on the problem itself. Okay. So see, in the data science, there is a process. Before processing your data, we need to clean it. We need to clean it. Okay. Clean, transformation, normalization. These are the all the tasks related to the data pre-processing. Okay. So before feeding data into the machine learning model, we need to pre-process our data. So these all comes under the term of pre-processing. Pre-processing. After pre-processing, you can send your data to the model. Clear? So now next is the data transformation. Anyone can tell me what is data transformation? Anyone?
Sir, changing the state of original data.
Yes, changing the data state of the original data. Any example?
Sir, data normalization can be a part of data transformation.
Yes, normalization can be a part of the data transformation. Good. Okay. Any other example that you can visualize?
So
I
like
can show
change
you. Oh,
values and
yes.
everything.
Sorry.
So changing the null values and everything.
I can show you a research paper. I think one of you suggested me try to show the things in the research paper itself. Not here, sorry. Yeah. List of, sorry, this one. Uh, yeah, this one. So okay, I let me show you. See. So see, yeah. I'm using some image here. This image. I'm using some kind of image, and I'm transforming this image into the DCT coefficients. So see, this is my image here. So I'm not directly using this image. I'm not directly using this image. What I am doing, I am transforming this image into the frequency component. Do you know what is image in computer science? Image is just a matrix. Image is just a matrix. For grayscale image, it is a two-dimensional matrix. For the color image, it is a three-dimensional matrix. that means you are having three plane, red, green, blue. So image is just a matrix of pixel values that range from 0 to 255. So instead of directly using the image pixels, I am transforming this image into the frequency component. I'm transforming this image into the frequency component, and that frequency component I'm using is the discrete cosine transformation. So you can say here it is written DCT, two-dimensional discrete cosine transformation. Okay. So first I use a blocks of 8 by 8 because my image is too large. So I use 8 by 8 blocks B by B, and then after that I transform each block using the two-dimensional discrete cosine transformations. Okay. If you want to see the mathematics, I can show you the mathematics of this discrete cosine transformation as well, but that is unnecessary to discuss in the class. Okay. And this I have also written here. Okay. So I used this kind of transformation. Okay, it is just an example. Clear? So in the research paper itself, you can have the different kind of transformations. Okay, so coming to the point, yeah. So transformation is the process of changing the format, structure, or value of our data. Okay. Transformation can be a two-stage. Again, I can show you the research paper. Two-stage, that means suppose I'm talking about image. Okay. Suppose at initial stage I apply one kind of transformation, that is DWT, discrete Wavelet transformation. Discrete Wavelet transformation. And after applying discrete Wavelet transformation, I can apply DCT, discrete cosine transformation. Cosine transformation. So it can be pipeline, that means two stage. You can have three stage. It depends on our data and application itself. See, so data may be transformed at two stage. First stage may you do something, then second stage you do something. Okay. So organization that use on-premise data warehouse generally use extract, transform, and load process. Okay. So this one is clear.
Yes, sir.
Okay, so all these are the notes. Okay. Now, what are the benefits and challenge for the data transformation? Benefit is the better organization, or sometimes you need to extract the features, important features itself. जैसे कि I use a discrete cosine transformation. After transformation, I performed something. So I was extracting some important features. Okay. So data transformation is used for better organization of the data. It is useful for both the human and the computer. And properly formatted data also improve the quality of our machine learning model. Okay. So these are the benefits. You can write a lot of benefits. There is no limit to write the benefit. And clear. So you can see the benefits, better organization of the data, always properly formatted data is good. It improves the performance of our machine learning model. Okay. So anything you want to ask till now? Data cleaning and data transformation. Hello.
No, sir.
Okay. I will give you the examples in the lab, the working example. I will show you on the model, some data set, then machine learning model, and we will see how cleaning is performed, how transformation is performed, how normalization is performed. For classification itself, we will discuss the Python code with some data sets. Okay. Now the challenges. So sometimes if your data is too large, If it is too large, then this transformation can be expensive. Okay. So you need to spend a lot of time and human resources for data transformation. Okay. So this you can say the challenge here. And again, which transformation is required is again a question. So it also depends on the data. If I talk about the image processing, we have a different kind of transformation. We have SBD, we have DCT, we have DFT, we have DWT. SVD stand for singular value decomposition. DCT stand for discrete cosine transformation. It is DFT means a discrete Fourier transformation. DWT is discrete wavelet transformation. So which one is good? Or all these are you can use in the image processing. Which one is good? So it depends on the application, but the where you are required this transform data. Okay. So this is again the question, okay, which transformation. So sometimes you need to play around in the research paper. What we did, whenever we are trying to propose some new work, we need to play around with the too many transformations, then see if which one is good for this kind of data and for this kind of application. Okay. So again, this is the challenge here. One most common challenge is the if the data is too large, then it can be very expensive. Okay, it takes a human resource and the computational resource as well. Okay. Okay, so again, if the data is too large, so performing transformation in an on-premise data warehouse after loading or transforming before feeding into the application can create a computational burden. Clear? So after loading and before feeding, there is a term transformation. So this can be a burden that can slow down the operation. Okay. And if you are lack of expertise, if suppose you are working on some image related data and you are not familiar with this, you are not expertise in this, then again this is a problem here. Clear? Hello.
Yes, sir.
Okay. So any other research paper you want to see, or I can continue further?
I think so. You can continue with this.
Okay. Okay. So this is example here. Suppose someone is working on medical data and he or she is not familiar with the relevant terms that might fail to flag disease name. Yeah. So this is again a problem here. So I can tell you one example. My friend uses SVM for mammogram classification. Mammogram classification for cancerous patient. Sorry, classification. Okay. So mammograms are what? Mammograms are the images. Mammograms are the images. So instead of directly using these images, he transformed or he extracted some important features of that image, and then these features he feed into the machine learning. That means in the SVM. Okay. So he learn something about the mammogram, what important features it can have, okay, using some statistical technique, or using some image processing application itself, and then he transform. Okay. So these I gave you the example for image processing related, but these are the some general ideas for the transformation, like aggregation. So aggregation is the most common transformation. So data aggregation is the method where raw data is gathered and expressed in a summary form for statistical analysis. Second one is the attribute construction. So it depends on the data. So instead of taking whole data, you can take some important attributes, So sometimes suppose you are having some data and you just transform this data and gather some important attributes. Attributes may be mean. I'm not sure what attributes we are talking about. So it can be anything. So some important attribute you have selected, important attributes, and instead of feeding the whole data, we can feed these attributes. Okay, so this method helps create an efficient data mining process, because if your data is too large, so instead of feeding all that data, we can transform this data and take some attributes, and then we can process it. Clear? So in my paper itself that I have shown you a research paper. Okay, this paper I also used this attribute actually. I will show you again once again. See, after this transformation, actually, what I did after this transformation, I used some kind of measurements, and then I selected this attributes, linear measurement. So instead of processing this image, first I converted into blocks. After that, I do discrete cosine transformation. After that, I transformed into linear measurement. That is two-stage transformation. And these are the some important attributes. These are the some important attributes of each image. So directly feeding this original image, I feed these linear measurements. Clear? So you can say the attributes. So yeah, attribute construction. So it depends again on the problem and data, okay, how you can construct the attributes. Okay. So these I have already told you. Spatial to frequency. Spatial, just like my original image is in the frequency domain. This is only for specific application purpose. A specific to. Okay. So these are not the general idea. Spatial to frequency. Okay. Discrete cosine transformation. If you want to write discrete cosine and or discrete Fourier. बहुत सारे हैं, not limited here. Discrete Fourier transformation. So these are specific to the application. Data integration. Integration means sometimes you need to combine two or more than two data into a single data. Okay. Combining data residing in different source. So you are having different sources here. You can combine all this data into a single unified data. So this you can see the integration here. ठीक है, बहुत सारे हैं. Manipulation, smoothing is generally used in the image processing. That means you need to remove the noise, or just remove the noisy data, clean the noisy data. ठीक है, manipulation is just changing or altering the data to make it more readable. So just manipulation, smoothings. Clear? So anyone can tell me what is the difference between data cleaning and transformation?
So in data cleaning, we basically like remove the null values if any and other unuseful
Yes.
data. And in data transformation, we are basically transforming the data for so that we can perform some analysis on it.
Yes. So yes, difference is clear to you. So I no need to discuss. Okay. Now the next is the normalization. Also, you can say comes in data transformation itself. Okay. But we can discuss it separately, because most of the time you will find we need to use normalization. So I will tell you the example. Okay. Suppose this is house data. Okay. So you are having these attributes: bedrooms, bathroom, a square feet living, a square lot. So suppose I'm talking about these four. What you can say about this data? These are the very small values and these are the very large values. So whenever you feed this data in machine learning model, what happened? It can be the possibility that this data can dominate your machine learning model. Yes or no?
Yes, sir.
So this is the problem here. So what we can do, we can normalize this data into some specific range. Maybe we can normalize this data into 0 to 1. So all the values will become in the range of 0 to 1. So this you can say an example of normalization. So normalization is a technique often applied as a part of data preparation. Okay? And the goal of the normalization is to change the value of the matrix column in the data set without distorting the difference in the range. So for machine learning, every data set does not require normalization. Keep in mind, every data set doesn't require normalization. It also depends. So the example I gave you may require the normalization if we are using the number of rooms or bathroom and square feet living as an attributes. Okay. So a common formula you can say, it is again not a fixed formula. There are a lot of formulas available for normalization, but this is for 0 to 1 or min max scaling. Okay. So suppose x is our original value, so we will find the minimum value, we will find the maximum value, and we just apply this formula. So all the values will be in the range of 0 to 1. We can see the example here. Suppose I'm talking about this one, 1180. So 1180, you need to find the minimum. So I need to apply the formula for finding the minimum. Okay. So suppose okay, ये है F2. एक्चुअली बहुत सारी रो है इसमें. So okay, F2. I can write here min. Okay, F2 say F2, sorry, 21615. मिनिमम 0 आ रहा है इसमें, कोई वैल्यू 0 है क्या? मे बी मिनिमम का फॉर्मूला तो यही होता है ना, मिन. ओके देन मे बी 0 है ये, नॉट नो. मैक्स चेक करते हैं. ओके मैक्स F2 F21614, sorry, equal sign. Okay, max here. So 0 and 13540. You can see this must be in 0 to 1. Okay, so this is an example for min-max scaling. Okay, so this is a normalization. This is clear why we use normalization.
Yes, sir.
In a particular data set, there may be the case that a particular attribute may dominate the machine learning model because the range in the value is very large. Some attributes maybe have a range between 0 to 10, or another may have a range between 0 to millions. So the larger one may dominate. So for this we need an example I have here written you. I no need to discuss this actually. Okay. Yes. Don't say. Okay, so name, year of experience, salary. Okay, so you can say salary will dominate. So we can normalize this. Okay, second example I discussed. Okay, this is clear normalization.
Yes, sir.
Okay, so then we can discuss. This is not in your syllabus, but I just want to show you because sometimes you will find what is standardization. So there is a difference between the standardization and normalization. So we will discuss in the next class. Okay. Anything? Any doubt till now?
No, sir.
Okay.